me, nothing quite says retro like an IBM 5151 monochrome display. And look at it in the dark, it looks tech noir, Matrix-esque. It's beautiful. There's one problem with this monitor, however, and that the little thing has a problem where it just, well, jumps around. It's not having a party, it's having a rather sad day with some sort of sync problem. So in this video, I'm going to basically take a look inside and hopefully safely figure out what's going wrong. So in the light of day, have a look at this thing. It's possibly the grubbiest monitor I have ever seen in my life. Awful, but it's still definitely salvageable. So as you saw in the introduction video, it was having synchronization issues. It was jumping up and down. So let's try and fix up this lovely wee monitor. First, let's make sure the monitor is safe to work on. And I'm going to use the handmade safety tool, which is just this, a piece of insulated cable, a screwdriver with an insulated end, and the cable there tied into the screwdriver. Let's get started. Now, these monitors look pretty straightforward to get into. There's just a whole bunch of screws on the bottom. So I'm going to start with the outer ones. This monitor has a manufacture date of March 1984. On the top of the monitor are these two tabs which can be lifted up with a screwdriver. I've just loosened them off already. So the 4 screws on the bottom of the unit and these 2 on the top should allow us to take the front CRT assembly off. Hopefully I've removed all of the screws, so I'll just take these out of the front. And then flip her over. So I was pretty stupid. I removed these 2 screws here. So I figured out the hard way that these 2 screws are actually holding this metal bracket in place, which has a transformer on it. So it's probably not a good idea to take that paper off. That paper was there for a reason. It's these screws, so there's 6 screws in total. 2, 1 on the lug here, 1 on the lug there, and then 1, 2, 3, 4 here. And that's all you need to take it off from the bottom, and then obviously the lugs covering the screws on the top. Okay, so now I'm into it. The safe thing to do is to dissipate any charge which is still coming from the flyback, which is here, to the anode, which is on top of the monitor. So I'll just slide this round a bit, and I don't know if you can make out from the angle where the video is at, but the inside of this monitor is absolutely disgusting. It is filthy. I'll try and zoom in a little bit for you. But I don't know if you can make that out there. It is ghastly. I've never seen anything so bad as this one. Yeah, I've seen some pretty horrible machines. Okay, so I've got my handy little tool that I've made, which is basically an insulated handle screwdriver with my cable wrapped around it with electrical tape. So I just want to make sure that I've got a good ground connection first. So I'll take one end off my multimeter, and it's just on continuity mode. So I'll just take one end off my multimeter here on the screwdriver tip, and then the other end to ground here. So we're completing a circuit, so I know that it's good. Okay, let's do this. Fingers crossed I don't die. I decided to move the earth rod round to the other side so I could get into the anode a bit better. So let's get into it. Okay, so one thing to note, in fact, you need to take off any jewelry you're wearing, and also any watches or anything like that. It could be conductive, they could get zapped too. Okay, this is the anode. I'm just going to go in and discharge. So one hand behind your back. This hasn't ever been removed because it's attached pretty well. It's looking good. Touching the connector on the anode now, and sorry this time people, no sparks. Now, the reason why there's probably no sparks is probably one of two reasons, or both. One reason is that this monitor hasn't been powered on in the last sort of, I don't know, 24 plus hours maybe. So a lot of that charge will have been dissipated. And the second reason is because a lot of these monitors have resistor-based dissipation built into the anode connector. So I've made this connection. I think it's now safe to work on, and any charge that was remaining in there, it should be gone now. Don't forget though that these big caps over here, these big caps can also still have charge in them, so it's very important to dissipate the charge there as well. I'm now two-handed. I'm going to remove the anode connector. Sometimes, oh, this one is really stiff. This might not come out easily. It's, oh, actually came out really easily. But I thought I was maybe going to have to get pliers to that, because this anode's, usually these are very like rubbery, but maybe with age this thing's become really hard. It's not rubbery at all really, it's sticky, horrible. Okay, so that's the anode off. I'm confident that I can start working on this. However, I'll just turn it around and have a look at these caps here. There's a big bad boy of a cap around about there. So what I'll do is just find the connectors on here. Get the right ones. Just short them.
And for you dirty lot, here's one last look at all the crud inside this beast.
Okay, so I cleared the monitor just with a brush, just to get all the smeg off the side of it, and just have a look at all of this. Absolutely disgusting. Yeah, that's from inside and just from the front of the monitor, but yeah, I don't... Yeah.
So now I've got this all cleaned up out here, I'm going to get this board out so I can reach into all these pots up here. There's a vertical hold and a vertical sink, amongst other ones.
Obviously there's a number of cables connecting things. Actually, that's probably a good point. I might want to need to take the cathode gun off first. I'm just going to pull that away. There's the end of the cathode. So these just need a little bit of a wiggle and they come off. So now that's done, let's get back to moving the logic board. And there's this earth rod here, I think. Yep, that comes out. Sweet. This is actually one of the easiest monitors I've seen to work on. It's pretty neat. Everything's very small. There's not much logic on the board, to be honest with you. It's very straightforward. So I'm just going to turn it around so you can see it a little bit easier, hopefully. And if I look at these three pots here, I don't know if you can make out the text which is on the side of the board. but the text on the side there says vertical hold or V hold, V size, and V line. So I don't think I want to amend the V line, but the vertical size and the vertical hold, I think one or potentially both of those is out. Now, as you can probably see, there's glue on each one of these pots here. So what's either happened is the pots have become dirty, and in that case, they might just need to be lubricated, or the pots have, they're just moving as they heat up and cool down. So what I'll do is I'll just try and clean them up first. I'm going to probably switch the monitor on with the case off, just so I can see if the monitor reacts properly. And then if I'm happy with that, then hopefully I can put it all back together and it can remain happy for the rest of its days. Okay, so whilst I'm here, I might as well just check the resistance of these three pots. I'm not really fussed about the focus because I know the focus is good, and the sub brightness I think is also fine. I've had the monitor running away, no problem with brightness. So let's just check the three resistances across the vertical lines here. So this first one is the vertical hold. So the resistance on this one from the spec sheet is supposed to be 100k ohms. Right, so we're getting a reading of 89. And the next one, the V size, vertical size, is supposed to be 250k ohms. And that one's coming in somewhere around 200. And then finally, the linear vertical is supposed to be 50k. Yep, 42. So all of them within relative bounds. Hopefully that means they're still okay. These pots, they've got glue on them. I don't know if you can see that, this horrible old yellowy stuff. And that's obviously when they're in the factory, they want to set them so they don't move about in transit or over the years. It's actually really difficult to get this stuff off because it's gone completely hard over the years. So I've borrowed an air blower to get these off. So just putting some more air on it. There it goes. Makes it a heck of a lot easier. Otherwise, I don't know how I'd get away with it. And there's the culprit. Okay, so after moving the glue off, I'm getting a lower value. I'm reading 64, which is definitely a lot lower. So it might be a scratchy pot. So if I turn this all the way to the left, hopefully I now get a resistance which is higher, which is, yep, that's 202, and it's holding. So, and the interesting thing about this as well is our original value on the vertical hold was 89, and I haven't moved it. I have moved the pot around, but as you can see, once I moved it back to its original position, the value is 50. And this one here, the value is, I believe, 250. The maximum value is 250. So all the way down, I'm getting that around 200. So half of that is 125. So this is where it was when it was all glued in place. And the value is really low, 68. So I'm going to increase the value, I'm going to increase the resistance on this. Take this down to about here. What do we get now? So we might want to go about 125. Let's see, bring it back a little bit. That's good enough for who it's for. Alright, so I've got those two values now sitting happier than what I was looking at on the original readings. So I'm going to put this board back in place. I'm going to put the end of this on, and I'm going to put the anode back on the monitor, and I'm going to fire it up, and hopefully nothing goes bang. This is hasn't been opened since 1984 probably, so let's hope that everything goes well. Alright, don't try this at home, kids, but I've not got the case on the back of the monitor, so that's why it's sitting on this bubble wrap, which is probably not the best thing. It's hopefully not too conductive, but I don't have any cardboard that's really suitable, so I'm just going to wing it. Let's just switch it on and hopefully it won't blow up. There it goes. At first glance, the vertical hold is fine, but the vertical height still looks to be smaller than I would expect. It's no different to how it was before, but at least this gives us an opportunity to check if the problem is still there. So far, I don't see it shaking like it was before. There was quite a lot of shake on the screen. So that might be a good sign. Let's just see if we can push something out of it. All right, there we go. So we've pushed the, I think that's the hold, which has gone there. But when we go back out of graphics mode, everything seems fine. So I just very quickly wrote a program, a really nasty program in QBasic, just to see what the different screen modes look like, and you can see that this here is jumping all over the place. Let's just do 20 lines instead of 23. And obviously that should just be 20 solid lines. It shouldn't be jumping around all over the place like this. So if we change it to screen, do rem there, that'll work on it. Yeah, so that's screen 0, and you can see no problems there at all. But if I change it to any sort of graphical mode, it seems to not like it. So here's low res, basically CGA, and you can see it's jumping all over the place like that. So what I'm going to do is, I don't think I can get at that pot, but I'll give it a try and see if I can get at that pot without disassembling the whole thing again and change it about. So as luck would have it, it turns out that you can reach the pot without taking the whole thing apart. And as you can see here, by moving the vertical hold to the top all the way, the hold is working fine. All right, so on this capture, you're seeing on YouTube, it's probably flickering like hell, but you just have to take my word for it. The screen here isn't flickering at all, so it's just the refresh of the screen. But when I run my test program, everything looks really good now, which is fantastic. And I can go through successive modes: low resolution, high resolution. It all looks pretty good. Mode 2. Yep, so CGA mode. Also looking really sharp, which is really nice. Okay, so that works. So let's just see if we can run Leisure Suit Larry now. Looking good.
So now that I knew it was worth salvaging, I thought let's get this dirty old thing looking a bit more shipshape. So off it went to the kitchen, got some soapy water, and the results, well, they speak for themselves.
So all things considered, I think that this monitor really is fantastic. I love how it's come out. Look at how clean that case is. It just looks so much better. Now, all that I've used on this is soapy water and a magic eraser in some of the tougher spots. And you can see that these are never going to come better. These scratches, some of them are really bad. And there's like blemishes in these around the side here. Don't know if you can make that out, but the actual monitor itself, it looks crisp, clear, it's bright. It's a bit overly bright there, I'll turn it down. Yeah, it's bright and it's lovely. For me, the monochrome monitors, the green screens themselves, take me back to my very first PC in I think it was late 1980s. So it's really nice to see this working perfectly well. So obviously not the hardest of fixes, I guess, but it certainly was a great result. So I'm really pleased at how this has turned out. So there you go, that's the IBM monochrome monitor, the 5151.
Well, that's about it for this episode of Al's Geek Lab. I do hope you have enjoyed the video, and as usual, if you have, please like and then subscribe and then hit that notification button so you get all the latest videos straight to your phone. Don't forget, I'm on Patreon, patreon.com/Al's Geek Lab. I'm also on Facebook, Twitter, Instagram, and of course, don't forget the website www.alsgeeklab.com. Thank you very much for watching. I'll catch you next time. See ya.